Let's try this again. Hooray, we did it. Okay. How's everyone doing with the homework assignment? I noticed not many people turned it in as of last night. That's okay. It's only due to today, but just checking in. Any question? No? There's a lot of questions. Okay. All right. Let's open it up and maybe we can clarify some things. Here, give me a second to save this and then we'll go to that. Today is October 4th. Okay, okay. Open file, recent files. Okay, this is our homework. This probably gave you some problems because I did not word the question well, right? Yes? Okay, so what am I asking here? Okay, I want you guys to create a data frame that has birth year as, let's say, like, it can either be either way, but really I want you to have a data frame that has birth year as the column. And then the values are the total number of home runs. And then the rows are each team. So you obviously have to aggregate by player, right? Because there could be multiple players who were born in the same year on the same team. Does that follow? All right. So columns are the birth years. The rows are the team IDs. And the values are the total number of home runs. It might take more than one step to get there. This is like a problem solving exercise. Okay. Does that help? Okay. What about number 2? Yes.
I had a question about number 1.
Okay.
The birth years, when you say columns in the birth, like, you mean that it's just one column of birth years, or you want like 1974?
That's a great question. I want, so it's spread, right? It's supposed to be wide. So I want each year to be its own column. Essentially, this is a 2-dimensional object we're creating, and I'm not trying to muddy the waters. If you wanted, you could have the teams be the columns, right? And you could have the birth years be the rows with the values filling out the matrix. Because essentially, this would answer the question, for example, do older players hit more home runs? Do younger players hit more home runs? Okay. Okay. Do you feel comfortable sharing your screen? Oh. No. Okay. Do you want to talk about your approach? No. Okay. Well, okay. I have a proposal defense this afternoon, so my time before the due date is a little bit crunched. Um, would you guys like to work on this for 10 minutes in class? And then we can have just, all right, let's do that then. I see lots of nodding heads. All right, let's spend 10 minutes working on this. And raise your hand if you need help. Like your office hours. Struggles. No, no, you're fine. Okay. Yeah, so we don't really care about the other stuff, right? So how we. Subset. So. Yeah. Right. So. Yeah, yeah. It's, you can't break. It doesn't work every time. All right, so what's the answer? Look at that. Is that? Is it over or under? Come on, we're show the solution. What else can help?
Okay, you isolated the things that we care about, right? We don't actually declare it. So in this problem, the first thing. How many home runs we get per team. So what does that sound like? Is that- Okay,
I just don't know how to like, I know how to get the tokens, but then I don't know how to like use that.
okay, let's do it very stepwise. You know that you want to get home runs, so do that part. Step by step. So we're gonna put Dave's team. You don't have to specify $11 sign. Yes, right. So now it's what things do you want? That's one of them for sure. So add that comma. No, all right, we're here. What's next? Four runs at each team. Yep, I think so. If you can't, we'll figure it out. We'll learn quickly. It will not look like we won. Yep, that's right. Okay, cool. Okay, so let's look at the top. Let's look at T2. Let's look at that. Nicely done. So now you have groups. But you see, this is a long. So this is what it becomes, right?
It's like, I knew like that was the layout, but I did not know how to get there.
Who, or no, older people, older players or young players? Just, oh, yeah, yeah, okay. That's okay. So. to you, about stuff. So that's okay, because there was some. Like, which is small, so. So now you can decide. Oh, yeah. All right, a number of you have answered the question, but let's go ahead and do it as a class.
Okay. This is going away. Dr. Robinson did not write a good question. My bad. Sad face. Okay. Okay. All right. So this is, we have to problem solve. This is not one-stop shopping. So we need to work through what data we need to basically get to the answer. So the answer is we want to have our columns as birth year, our team ID is rows, and then the values be the total number of home runs. So how do we get there? Okay, well, we know the columns that we care about are not that many. We don't need that whole data set to work with. So the first thing we're going to do is we're going to subset, pull out the data that we care about. Let me load up the data. That would be helpful too. Don't get excited. You're not going to say anything. You guys are doing a good job on the exams, by the way. So far, I've only had A's. So. There it is. Okay. All right. Subsetting. So the columns I care about are team ID, birth year, and home runs. Did I name it something different? You didn't load? There we go. Okay. The next step, once we have our data, is we want to find the total number of home runs for each team and birth year combination. So when we want to aggregate or group things, we're going to use our group by function, right? Move by tidyverse here because I didn't do that yet. The input data is DF, our subset, and we can group by two things. We can group by many things with group by. You don't have to do one. So in this case, it's team ID and birth year. I'm going to do this step by step. You can certainly use piping, which is the pass to kind of put all these things into a single line. Both are completely valid. Okay. So when I look at the output data frame, our data doesn't look dramatically different, but Tidyverse has created groups for each one, for each set. Okay. So now I'm going to take that grouped data and we're going to put it into a summarize function because we want to find the total number of home runs. Our input data is what? Give me the name of the object. It's DFG. And then we're going to make sure we want to give this, we're going to name our column, our output column. So I'm going to call it total. And what I want, I'm going to use a sum function because I want the total number. So when I look at my output, we're getting close now. So now we have a data frame that's in a long format that has a total number of home runs for each team and birth year combination. Okay, so we go back to the original goal, which is to get all our birth years in columns. We're asking, we want to go from a long format to a wide format. So this is where we're going to use our spread function. Okay. So what's our input data? Yeah. Which part? Okay. Okay, so make sure that the names here are all in bold. His name is not mentioned. So how do you check the names? Let's quickly look at that. Right? So, right. So, check those out and make sure that. Do you see it? Okay. All right. So what's our input data here? It's DS. The key, this is the column that we're going to split apart into, this is the column where we're going to take the values within it and split those apart into their own columns. So that's going to be birth year. And then the last argument is what is the name of the column that has the values that we're working with? In that case, it is total. Dun, 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 dun. We have achieved our goal. We have our birth years as individual columns, and then our teams are on the far left there as rows. Don't stress out about these NAs because there wasn't players born like for this combination in Arizona. It just means there's no data, right? So that's why there's NAs there. And then as the players get younger, right, they start hitting more home runs. Okay. So the take home, I think a little bit from this exercise, and this is what I'm going to start trying to get you guys to do, is move away from, you're getting enough skills now where I want you to try to start synthesizing them. and trying to recognize, oh, to solve this problem, I need to use this one, and then this one and this one to get to the output. So, and that's okay if you need to ask questions and things like that, but that's what coding is it's not just like, it's not A equals X often. When we're working with our data, we may have a multi-step thing that we have to do to really get to the answer that we want. Okay. Does anyone have any questions about how we approach this? Okay. How do y'all, go ahead.
So when you say like aggregate by player ID or by player, like we didn't do anything with that, like per se. So like I don't know exactly what that means.
So what that was trying to get at here is that when we do this group by here, we are aggregating all the player information into a team and birth year combination. That's what again, that was not well written. That's what I was trying to say. Okay. Go forth and conquer on this homework. We're gonna spend a little bit of time, actually, since we were working through that. We'll talk a little bit about merge for the rest of the class and see how we feel about that and maybe start doing functions. Okay. Since my notes from our last class is that we just started talking about merge as we closed out. Okay. All righty. Let me clean out my stuff. All right. Okay. So go ahead, we're going to load up that Metcar data that we were working with last Thursday. Cars, Metcars. Okay. This is data that's just part of your R, so you don't have to go anywhere from the folders to load. It's just part of R. Okay. So we're gonna split this data up into two separate data frames because we want to put them back together. That's what we're going to practice. Okay, so you may remember we had a little bit of discussion that these car makes and models are saved with row names, and we want to be able to access that information. So I'm gonna make this a new column. So how do I make a new column from these row names? You guys are gonna walk me through that. All right, so we're with the data frame. I'm gonna make a new column, cars. We have to call a dollar sign, right? Because when we work with data frames and we're referring to a column, it's cars, dollar sign. This is outside of tidyverse functions. I know it's how they can make it confusing. All right, we're gonna call this make. All right, how do I call the row names of a data frame? There's no trickery here. Row names. Dun, 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 dun. Okay, we're going to assign these values to be their own column in our data frame. All right, so it looks like the information is duplicated, but in fact it's not. Now we have a column called make that has all that information. So now we can call it. Now we can reference it. All right, so now I still need to split up my data frame so I can put it back together. Okay, splitting the data frame. All right, so I'm going to do this by just grabbing a subset of columns. So MPG, cycle, cylinders, excuse me, and displacement. So that's our first one. Our second data frame we'll make is we'll grab the weight, the gear, and the carburetors. Okay. I forgot to do something I need to do. I need to add the make here. My bad. We're going to see in the second line. Okay. All right. So you guys got two data frames now? On your heads? Yes. All right. Okay. We haven't done anything. We just split them apart, subset of them. One thing that we've kept is we made sure that each one has the make. The reason for this is that we're going to use this as a column to put them back together. Okay, so to refresh your memory, if you want to combine two data frames, you can use, I'm just giving this as an aside quest, you can use cbind. Does anyone remember why it is not advisable to use the cbind function? What's that? It can mix everything up. Yes, you can lose data integrity. It's like, sure, I'll slap rows 110 together. Doesn't matter if they're matched or not. A better option is to use merge, which we'll do now, or join. Okay. All right. So what does merge look like here? All right. So merge has 4 arguments that we need to pay attention to. The first 2 are X and Y. Those are the data frames that we want to smoosh together. So our X data frame is going to be car's power. Our Y data frame will be car morph. Okay. The next argument actually has three options. This is our by argument. So this is asking, well, what column should I use to match everything up with? If the columns have the same name, you can just use by. If the columns have different name but the same values, because let's face it, sometimes maybe you use an uppercase for one data frame or a lowercase for another, right? RC those different things. You can just say, well, it's called in the X data frame this thing, and it's called in the Y data frame this thing. Okay. All right. In our case, we used the same column name, so we're just going to say by, and I'm just going to say make. All right, our last argument is the all. How do I explain this well? This is telling R how you want them to be joined. So do you want everything to be matched up 1 for 1? So if you had 10 rows in one data frame, 10 rows in another data frame, the output would have 10 rows, equally matching. All X, we can practice this. Let's say car power had 10 rows and car morph had 5 rows, right? So if you wanted to keep all 10 rows in X, you would say all X equals true. If you wanted to just keep the 5 rows in car morph had 5 rows, and you would just say all Y equals true. If these are two different, like in our little example here, and we just use all, it's going to default to the shorter length data frame. So in this case, the output would be true in our hypothetical situation. Okay. So we've got the same number of rows here. So we're just going to use all, and we'll have all the outputs will be equal. Okay. All, this is a logic. Blue equals true. Okay. So the output just has, we've now joined by make, and it's put together the 2 columns in the right order, the 2 sets of columns into the right order. Let me hammer home this point about the differences. So I'm gonna, for grins and giggles, I'm just gonna grab the first 5 rows of car power, of car morph. There we go. Okay. Call it cars morph 5. So do. Just using indexing here. Just give me the first 5 rows. I'm keeping all my columns. Okay. So now I've shortened it, right? All right, so let's use this one to practice this. Try to better see what happens when we use that all argument. So cars power has 10 rows. I'm just showing that. Okay, it has 32 rows. That's not important. All right. And cars morph is definitely going to be shorter. Okay, since this is 32. Okay. Okay. So same deal. Cars power is our X data frame. Our Y data frame is going to be our cars morph 5, the shorter one. What's your dealie? Being weird. So our buy is still make. And now I want to keep everything in Y. So what do I say? All Y equals true. So if it works as I suppose it will, then we will end up with a data frame that only has 5 rows. That's why. Okay. And it does. Data frame only has 5 rows. Okay. What happens if we do the inverse? So now we're going to set the all argument to be all X. Changing this to DM3. So the only thing I'm changing here, instead of keeping all the rows in Y, is I'm telling you to keep all the rows in X. Okay, what does that look like? All right. So because we kept everything in X, which had 32 rows of information, and our Y data frame only had 5 rows, right? It was missing information. So the output has a bunch of NAs in it. Only 5 cars actually have the full set, right? Because there was only 5 bits of information in our Y data frame. Cars more 5 to fill in. So that's why you see all these NAs here. It's like, okay, I put them together, but we're missing some information. This is going to help later. When all Y is equal to true, this is called a left join. This is going to be important later. When all X equals true, this is called a right join. And these are just because this is on the left and this is on the right. Okay. All right, guys. Sorry you guys late start. I appreciate your attention. Give a shout by email if you need to meet up. So.